video. Looks good, sweet. Alright, so this recording I'll be able to like share it with you. I don't know if I'm gonna have to like chuck it on YouTube or what, but it'll work. Okay, so let's have a look at this exam question. Projectile motion. So golf ball's hit from the ground with an initial velocity of 20I plus 0J plus 15K meters per second. I represents motion horizontally forward, J represents motion horizontally left, and K represents motion horizontally up. So that's going to be really important here, right? Especially that motion up. I don't know why it says horizontally, probably should be vertically. After being hit, the golf ball experiences gravitational acceleration and a hook of 4J meters per second squared. So it's giving me some initial conditions. The first thing that I want here is to know how far the ball will hook to the left, and then I need to know the total distance that it will travel in order to get this. So both of these things to me, I look at and I see displacement. I care about displacement to get these. The thing that makes it complex unfamiliar, it doesn't tell me how to get to displacement. It's also in the 3 dimensions. It's added something aside from gravity for my acceleration. So there's a bunch of extra parts here. So I just got to think really, really carefully. I'm going to start as always with my acceleration vector. So I'm going to start by noting that A is going to be equal to, now it's got gravitational acceleration. So that's going to be my K, because it says that K is about vertical. So gravity is going to be that negative 9.8 K hat. And I've got this hook as well of 4J. So straight away, it's different to what we've seen before. I've got this J component in here now. I don't actually care about acceleration. I'm going to integrate now to get to velocity. So I'm going to note that velocity is the integral of acceleration with respect to t. So my velocity is going to be, I don't have an I component, but I'm going to end up with an I component, plus 4t plus another constant, because that 4 will become 4t now in my j. Take now my negative 9.8, oh well, I'm still going to write plus here rather, 9.8t plus c3k. Cool. So now I'm going to think, how do I get these c1, c2, c3? I am thankfully given information about my initial velocity. So that's going to be what I'm going to use here. So I've got my velocity here at any time, and I know that my initial velocity is equal to 20I plus 0J plus 15K. Yeehaw. So how I'm going to solve for this in this case, I also know that my initial velocity is going to be equal to, anywhere that I see a t, I'm going to sub in 0 now. So my I component still just has that C1. There's no t there. My j component I'm going to sub in that t, and then my k component I'm going to sub in that t as well. So it's got to equal C1 plus C2 plus C3K. So in this case, it's nice and easy. I can see straight away that C1 equals 20. I can see straight away that C2 is going to be 0. And that C3 is going to be 15. Cool. So now I can sub this back in. So now I've got velocity at any time, which is going to be that 20I plus 4tj plus negative 9.8 t plus 15 k hat. Groovy. Last step, let's integrate again. My displacement is the integral of velocity. So I'm going to have now 20t plus c1 I. I'm going to have 4t squared onto plus c2j. And I'm going to have negative 9.8 t squared onto plus 15t plus c3k. Alright. Again, I want to think about what are my initial conditions. How can I get this C1, C2, C3? It doesn't tell me anything at all about, and I will scroll back down there, Kathy. It doesn't tell me anything at all about initial position other than it's hit from the ground. So I can make a bunch of assumptions here. I'm just going to assume that it starts at 0, 0, 0. I'm allowed to do that. So assume the initial position is 0, 0, 0. This would mean that C1 equals C2 equals C3 equals 0. They're all going to be 0. So now I've got my displacement expression, which is 20ti plus 4t squared onto j plus negative 9.8 t squared onto plus 15t k hat. Cool, nice. So these initial steps are literally just to get me to a position to answer question A and B. Now that you've seen this problem, I guess it could be a valid CF. It's pretty gross CF, but there's a lot of marks in this because there's what, like 16 marks usually for CFs in your exam. This would eat up most of, like a good portion of those. And we usually like to see 2 CF, 2 CUs. Gives you a bit of a chance at a few. Alright, so I'm going to think about my actual question now. First of all, I just want to know how far is it going to hook to the left. So how far left am I going to go? So I'm going to double check. The hook was in my J component. So I'll need to know that. I need to know the distance the ball will travel. In order to get these, distance it will travel and how far it is to the left, I need to know at what time does it hit the ground. That's going to be my important thing here. When in doubt, time to hit the ground is a good starting point for any of your projectile motions. If you don't know what you're looking for, find time to hit the ground. Now, when will it hit ground? So I need to know what does t equal when k hat equals 0. I want to know when is my height 0? That's all I care about here. So I'm going to let just my k component equal 0. And I just so happen to get a really, really lovely quadratic. Nice. You're crazy if you don't use quadratic formula for this or the equation solver on your calculator. I didn't bring my calculator, so I'm going to steal Arsu's right now. You got probably solve on this? Okay. Apps, polysolve. Kathy, have you got this one just yet? Okay, we'll sort that for you. Nah, it's all good. This one works great, guns. Cool. Got negative 4.9. And I got 15. Alright, so I get 2 answers. Both make sense. One is 0. That checks out. The other answer is 3 point, I'm going to round 3.01. So I care about, obviously, the 3.01, right? That's the time when I hit the ground. All right. Now I can do part A. So the hard thing here is, right, you've got to know what you need in order to do these problems, right? So part A, I can do it now because I know what time it hits the ground. How far will it hook to the left? So all I care about is my movement left, which is my J component. So I'm just going to sub my time into just the J component. So then that's going to look like, what's that, 4 times 3.01 squared all on 2 is about 18. Whoop. Yeah. 18.12. Cool. I'll make that obviously an 18. It's asking me how far. Let's put meters on this. That's the units that it's using. So it's going to move 18 meters to the left of my starting position. Cool, nice and easy. I'm going to have a look at part B now. Determine the distance the ball will travel. Now, this is different to displacement, right? So what I'm going to do for the distance that my ball will travel for part B, usually this is really, really straightforward, but I'm in 3 dimensions here, right? I've got an I, a J, and a K. K is my vertical movement, but if I look at like a top-down view, this is my bird's eye. Here's my ball. I know that it goes 18 meters this way. I know that it hooks left by 18 meters. I don't know how far it went in my I component, and I don't know this last side length here, hey? So in this case, I'm gonna have to find my I component, and then really I'm gonna use Pythag. Alternatively, if you think way back to unit 1 vectors work, I'm going to find the magnitude of my vector. And if we're thinking external exam, totally fair game, because vectors is back on for the external exam, right? So totally fair game. All right, so let's do that. So I need this I length here, okay? So to get that I component of my displacement is going to be subbing in T of 3.01. So 20 times 3.01, and I get a result of 60.2. Yep. So then the last thing I need to find my distance, it's the hypotenuse. That's nice and easy. It's also, like we said, this is just a vector now. So my distance is going to be the square root of my I component squared, which is 60, plus my J component squared, which is 18. And I get a really lovely answer. Ooh. Soza. Bear with me. I get a lovely answer of what's it done? It's done a weird. Oh, I put something in wrong, sorry. So I got an answer that was 19, which is obviously incorrect because my hypotenuse can't be 19 with these side lengths. There we go, I missed a 0. Would that have affected my mark that much? No, I would have lost 1 mark at the very, very end for that. But it's also a nice thing, like I looked at that number 19, I was like, oh, that's not right. So just keep that in your brain too sometimes. There we go. Still not that much further though. But it travelled a total distance of 60, I'm going to trust this number that it says, 62.86 metres. I can round to 87 if I want to, but I'm just going to leave it. So that's how far I went. Done. Marks wise, you'll get a mark for your acceleration, you'll get a mark for your velocity, you'll get a mark for your displacement, you get a mark for, yep, I need to know when the time when the ball lands, about 7. Definitely on an EA, probably 7. Oh no, look, I've made a few assumptions in here, haven't I? So I'd need to sub these values in as well. So we're up to 9. It's a big boy. Big hefty question. That's all. Feel like the end of the world? It's not too bad. Okay, so actually I should plug this back in. I'll trim this last part of the